Simplifying complex rational expressions. A complex rational expression is a rational expression whose numerator or denominator or both is a rational expression. Using method 1 to simplify a complex rational expression. To simplify a complex rational expression by method 1, first, write both the numerator and the denominator as fractions. Second, write the complex rational expression as the quotient of two rational expressions. A over b divided by c over d equals a over b division symbol c over d, where b, c, and d are non-zero. Third, divide the rational expression. When we have a complex fraction, that means we have several fractions within a fraction. A over b is a fraction, c over d is a fraction, and then we have our overall fraction, where a divided by b is the numerator and c divided by d is the denominator. In this example, simplify by method 1. 12 over x divided by 18 over x cubed. Method 1 is the best method to use when your fraction is written like this. What we want to do is take the fraction on top and write it first. Then we write our fraction bar as a division symbol. Then we write what's on bottom behind the division symbol. Now we could work it just like we would work any division problem with fractions. I would have 12 over x times x to the third over 18. 12 and 18 share a 6. 6 goes into 12 2 times. 6 goes into 18 3 times. My x cancels with my x to the third, leaving me with x squared. So my final answer is 2x squared divided by 3, or 2/3 with the x squared behind. Simplifying complex rational expressions. Using method 2 to simplify a complex rational expression. To simplify a rational expression by method 2, first, find the LCD of all the fractions in the numerator and denominator. 2. Multiply by 1 in the form LCD divided by LCD. 3. Simplify the numerator and the denominator to polynomials. 4. Simplify the rational expression. In this example, simplify by method 2. 3 over x minus 1 over x squared divided by 3 over x squared minus 1 over x to the third. In this problem, we have 1, 2, 3, 4 fractions within a fraction whose numerator is 3 over x minus 1 over x squared and whose denominator is 3 over x squared minus 1 over x cubed. Using method 2 to solve this problem, we want to look at x, x squared, and x to the third. Then we want to multiply it by something that will cancel out all of those terms. When you're looking for the least common multiple, you always look for the largest exponent, which in this case is x to the third. So we want to multiply this fraction by x to the third over x to the third. So what that will give us is 3 over x times x to the third minus 1 over x squared times x to the third all over 3 over x squared times x to the third minus 1 over x to the third times x to the third. If it helps you with reducing, you can write all of your x to the thirds over 1, making them each a fraction. X cancels with your x to the third, leaving an x squared. So I have 3x squared minus my x squared cancels with my x to the third, leaving an x to the first, and 1 times x is x, so that's my new numerator. Looking at my denominator, x squared cancels with x to the third, leaving x, and 3 times x is 3x, minus x to the third completely cancels, and 1 times 1 is just 1. Now looking at my numerator, I have 3x squared minus x, which means I can factor out an x. That leaves 3x minus 1 over 3x minus 1. The 3x minus 1's can cancel, so my final answer is x. In this example, simplify 3 over 4x squared minus 2 divided by 4 minus 5 over 8x squared. Looking at the original problem, I have a fraction, a whole number, and a fraction. I can easily change those whole numbers to fractions by writing them over 1. Anytime I have more than one fraction in either the numerator or the denominator, the easiest way to solve this problem is by method 2. I want to look at 4x squared, 1, 1, and 8x squared to decide what my least common multiple should be. For 4 and 8, my least common multiple is 8. X squared and x squared, the largest exponent is 2. So I want to multiply this fraction by 8x squared over 8x squared. So this equals 3 over 4x squared times 8x squared minus 2 times 8x squared all over 4 times 8x squared minus 5 over 8x squared times 8x squared. Now we want to cancel what we can. 4 and 8 cancel. 4 goes into 8 2 times. The x squareds completely cancel. 3 times 2 is 6. Bring down my minus. 2 times 8x squared is 16x squared. All over 4 times 8x squared is 32x squared minus 8 and 8 cancel. X squared and x squared cancel, just leaving a 1, and 5 times 1 is 5. 6 minus 16x squared has a greatest common factor, but 32x squared minus 5 does not. So my final answer is 6 minus 16x squared divided by 32x squared minus 5. In this example, simplify 25x squared minus 4 over 9x squared minus 16 divided by 25x squared minus 20x plus 4 over 9x squared minus 24x plus 16. I have a numerator and a denominator. My numerator has a single fraction and my denominator has a single fraction. So the easiest way to solve this problem is by using method 1. I want to translate this fraction bar to a division sign. If you're confident enough, you can go ahead and flip and multiply and factor all in the same step. 25x squared minus 4 over 9x squared minus 16 divided by 25x squared minus 20x plus 4 over 9x squared minus 24x plus 16. That gives us 25x squared minus 4 over 9x squared minus 16 times 9x squared minus 24x plus 16 over 25x squared minus 20x plus 4. 25x squared minus 4 is the difference of two squares. So I have 5x minus 2 times 5x plus 2. That's over 9x squared minus 16, also the difference of two squares, 3x minus 4 times 3x plus 4 times 9x squared minus 24x plus 16 is a perfect square trinomial, which means we'll have 3x minus 4 times 3x minus 4 over 25x squared minus 20x plus 4 is also a perfect square trinomial, so that gives me 5x minus 2 times 5x minus 2. 3x minus 4's cancel. 5x minus 2's cancel. So my result is in the numerator 5x plus 2 times 3x minus 4 divided by, in the denominator, 3x plus 4 times 5x minus 2. In this example, simplify x squared minus 9 divided by x squared plus 2x plus 1 all over 2x squared minus 6 divided by 4x plus 4. I can use method 1 or method 2 to solve this problem. Given that I have one fraction over another fraction, method 1 is going to be the fastest. So first thing I want to do is rewrite it as a division problem. To save some space, I'm also going to factor. Starting with x squared minus 9, that's the difference of two squares, x minus 3 times x plus 3, divided by x squared plus 2x plus 1. I need two numbers that multiply to be 1 and add to be 2, x plus 1 times x plus 1, divided by 2x minus 6. I can factor out a 2, which leaves me with x minus 3, and that is divided by 4x plus 4, which has a greatest common factor of 4, leaving me with x plus 1. Now I'm ready to flip and multiply. So I have x minus 3 times x plus 3 divided by x plus 1 times x plus 1 times 4 times x plus 1 over 2 times x minus 3. Now we want to cancel what we can. I can cancel an x minus 3. I can cancel an x plus 1. And I can reduce 4 over 2. 2 goes into 2 one time, and 2 goes into 4 two times. So my final answer, 2 parentheses x plus 3 all over x plus 1. In this example, simplify a squared divided by b minus b all over 1 over b minus 1 over a. For this problem, we have 1, 2, 3, 4 fractions. I can say 4 fractions because I can change b to a fraction by putting it over 1. My best choice is method 2. And remember, I have a numerator and then a denominator of my large fraction. Deciding what to multiply this by, I need to look at my denominator for the 4 fractions. I have b1, b, a. Our LCD is going to be a times b. So that equals a squared divided by b times ab minus b times AB all over 1 over B times AB minus 1 over A times AB. And remember, if it's helpful, we can always put the AB over 1. So I have A squared over B times AB. The B's cancel. A squared times A is A to the third minus B times AB is AB squared. For my denominator, I have 1 over B times AB. The B's cancel, and 1 times A is A minus, I have 1 over A times AB. The A's cancel, and 1 times B is B. So now we want to see if we can factor. So if I factor out an A, I'm left with A squared minus B squared all over A minus B. This can be factored further. So bring over the A squared minus B squared, difference of two squares, A minus B times A plus B divided by A minus B. The A minus B's cancel, so my final answer is A times A plus B. Simplifying complex rational expressions. Method 1. Writing a complex rational expression as the quotient of two rational expressions. This works best if you have one fraction in your numerator and one fraction in your denominator. Method 2. Multiplying by LCD divided by LCD. This method works best when you have two fractions in your numerator or two fractions in your denominator or both.